Welcome everyone. Thank you for coming and spending the next 2 hours with us. And we have a really fun lineup of people from the Filecoin and IPFS ecosystems who are going to talk to you about a bunch of interesting things. And I'm going to kick it off with a talk just kind of outlining what IPFS and Filecoin even are. So even if you're familiar, I hope there's some learning here. And if you've never heard about IPFS and Filecoin and you're still trying to figure out what the difference is, and you're definitely in the right room, then I'll kick it over to David, who's going to talk about NFT Storage and Web3 Storage, two really great products that make it super easy to store and retrieve files on IPFS and Filecoin. And we'll have Danny from the Filecoin Foundation talk for a bit and about the use cases that he's seen in the Filecoin Foundation universe kind of. And then Pooja will wrap it up with a little bit of an outlook of 2022 and beyond, and to give you guys a sense for what's on the roadmap and what's coming up. Let me get started by just kind of outlining the different organizations and kind of things that we'll be talking about. I actually work for a company called Protocol Labs, which is an open source R&D lab and that's building protocols such as IPFS and Filecoin, where we started this years ago, but now these projects they're all open source and they're maintained by a growing community of people who are building them. The Filecoin Foundation is the steward of the Filecoin community, and then we have IPFS. I think the easiest way to think about it is really just it's a peer-to-peer version of HTTP, and I'll kind of walk through what that is, but that's probably the easiest way to think about it. And then Filecoin you can think of as the Airbnb for cloud storage. And I'll dive right into kind of outlining what that looks like. And cool, so I'll split my kind of 40 minutes into 4 sections really, and then Q&A. And I'll talk about IPFS and Filecoin, what they are, how they're different, how they complement each other. And then, because this is a workshop, I want to share some of the tools that exist for builders, and then kind of open it up and talk about Web3 a little bit more broadly, and close out with sharing a few learning resources that you guys can all use to kind of get started with the game. And I was thinking how to start this, and I think so I've only been with Protocol Labs for about a year, and I spent most of my time before that working in very traditional in the business world, and I got really tired of it. And the main reason why I got tired of it is because of how the web is organized. I kept building products that are seeking to attract users and build great things, and then lock them in and exploit them. And that kind of sucks. The internet today sucks. And I think it's fundamentally because it's centralized. And you guys have all heard that, and I think IPFS and Filecoin play a key role in moving us kind of to the right hand side of that slide towards a version of the web that's more decentralized, maybe even fully distributed. And I'm going to talk about how IPFS and Filecoin are a key piece of that puzzle. Not the only solution, but I'm hoping that we all can work together to make this vision come true. And let me just spend one more second on this with 2 headlines from the last year, right? That kind of illustrate what the problem is and why the internet needs to be better and why we need to work together to make it better. The first one is the Washington Post that's kind of pointing out the third outage in a month and kind of highlighting the weaknesses and the weak points in the internet today. And because it's centralized around that one company, and if that disappears, we have a problem. And you've all heard that kind of this problem of you give your data to some company and then they do whatever with it. I think the common examples are Facebook, Google, Twitter, those companies, but it goes deeper. 2023, a company that sequences DNA, they sold all that data to a large healthcare company. And so the Time magazine is asking you, should we be concerned? I think we should be concerned. And I don't really understand why the internet is set up this way and why it shouldn't change. So hopefully we can move to a world that's silo busting and fully distributed, where the users power the service and that's censorship resistant, that like promotes freedom, privacy, and that's self-verified, and yeah, just like a more resilient, more censorship resistant version of the web. Cool. Great, and with that, I'd like to kind of get started with what IPFS is and why I think it's like an important piece of that puzzle. And so IPFS stands for Interplanetary File System. File system just means files and folders, pretty straightforward. And we call it interplanetary because it's designed so it can actually work even if you're on Mars, right? So that's kind of like the best way to kind of describe it. But like, if you're on Mars and you retrieve a file from Earth, and then somebody else on Mars wants to retrieve that file, you can actually retrieve it from the other person that already retrieved it on Mars, rather than like going all the way back. And obviously that also works on planet Earth. You don't actually have to live on Mars, so that can be true. But like IPFS is distributed, there is no central server, and it's resilient and really kind of offline first, right? So if you're not connected to the internet backbone, then you're still going. And that is how IPFS kind of operates the web. And how does it do that? I think like the really important thing, and we kind of sometimes gloss over it, this idea of content addressing. But that's, like I hope like I can kind of translate some of the excitement that I have for this. But that's, in my mind, like a genius idea. Like what IPFS does, it addresses content by what it is, not by where it is. And that's really important, right? Like, so you can now replace a location with what we call a content identifier. And kind of like to illustrate that when we save data today, like locally, you just save it on your drive, and then you have what looks like file, and or a drive, and then like the path to that file. In Web 2, pretty similar, except you're also retrieving that data, but you're retrieving it from the web, and you're connecting to some domain, which is a location, like some IP address, and it's the same thing, and then a browser kind of like makes it look pretty, and it's in front of your screen. And so IPFS, we're also obtaining files from a remote location. However, the key difference is that we don't really need to know the location of the content. We just need to know what's called the content identifier, right? So ultimately, the content can even be in multiple locations. It would have the same content ID, and you can retrieve it from any of those locations or from multiple at the same time. And really let that just kind of like sink in for a bit, right? Because you had location-based like central points of failure. With IPFS, you have a whole range of folks who can now serve you content. And I'll dive now kind of next into what that technology looks like. So what IPFS does is like you have a piece of content, whatever, hello world file. You then run a cryptographic hash function and turn it into, give that content, you don't turn it into, you give that content and kind of a unique fingerprint called a content identifier. The same content will always have the same content identifier. And you can also kind of revert back, right? So if you have a content ID, you can always reproduce it if you have the original content, which, I don't know, like that's interesting, and I'll talk about that because now you have like verifiability. So if somebody gave you a piece of content and it matches the CID when you run the hash function again, you verify that it's actually the same piece of content that you requested. The folders are kind of the same thing. I just wanted to put it here, like folders are really just kind of special kinds of files that have multiple files in them, or list of files. And so it's the same principles kind of hold true because a folder is just a different kind of file, and it will also just get a CID, a content identifier. That means that we can represent a folder or even a full file system using content address structure. Okay, now it's going to get like a little bit more messy, but I wanted to kind of like bring that to life. As you see kind of on the screen here, you have a top-level folder that has a content identifier. You can call that the root content identifier, and it has two entries corresponding to two folders. And those folders have other entries corresponding to files, right? So you have like a couple of photos, and the content, like each entry has a different fingerprint, and kind of visualizing that with the colors here. this content address type of graph is what we call a Merkle DAG, so directed acyclic graph. And these Merkle DAGs are used by IPFS to allow us to move from a location-based addressing to content-based addressing in just a single step. And what we're really just doing is we're replacing a location, right, like the folder up top there, with a root content identifier of a content. All the subpath stay the same. And that allows us to do two things. And let me just bring that to life. Like, what do you do if you wanted to copy the file of the Doge of the dog here? And it would really mean two things. Firstly, you don't really have to copy the file. You just modify the folder to reference the content. And because to IPFS, two copies of the same file have the same identifier, to IPFS they're the same thing. And we call that deduplication. So that's like important for a number of reasons, but that's kind of the first thing. And the second thing that happens is because we changed the folder, right, because we added another file to it, the fingerprint of that folder also changed. So we have to update the upper folder too to reference the new fingerprint. And that's kind of like what you see there new with the, I think it's like green parts around it. And the fact that a CID always represents exactly the same piece of information, unlike a location, right, where you can change what you're actually retrieving as a location, you have this great quality of verifiability. Cool, so now we understand the content addressing piece of it, but now how does it actually work, right? So your content has an address now, but now you need to retrieve it. And that happens with this network, right? So you have the swarm, which is a network of peers, and a peer is one node in a peer-to-peer system. And like, forget about IPFS for a second, right? Like let's just like in this room, if I think about a group of people and I want to address one of you, I need to know your name, I need to know that that's David, and I need to have some way to identify, we need to have a common language, like we both need to speak English or whatever else. And we need to be able to verify that David is actually David. I know David, so I'm like, yeah, I know this is David, but he could also show me his passport or something if we never met. Same with IPFS, right? Like you need and the peers in the network. Each peer has a unique identifier, their name, we call that a peer identifier. And this identifier is linked to a cryptographic identity, which allows each peer to communicate securely with other peers through an encrypted channel. And peers also, and that's like the interesting part here, like also need to be discoverable and routable. And we do that with something called the distributed hash table, DHT. And think of a DHT really like a phone book, except there's no one single entity that like prints this phone book and like maintains it, but it's maintained by all the nodes. And the distributed hash table has two columns. It has a key and a value. And those are kind of used for the routing. So let me just bring that to life, because this is like you can see here kind of different nodes add different rows to that table, which then gets longer and longer. But no single node has the entire kind of DHT replicated in their node. So when you have this DHT, you have on the one side the keys, which are content identifiers or peer identifiers, and then you have the values that are associated with those. And so keys are either the content ID or the peer ID, and if I upload or make a file available on IPFS, I will add a row to the DHT declaring that this PID, my peer ID, has a specific content identifier, and I'm able to kind of like advertise that to the network. I also publish information on how you can actually connect to me as a peer. And then other peers can come and query that DHT, that telephone book, to find which peer is providing which content ID. And so you have two components here. You have the content discovery, where you match a peer ID with a certain piece of content that they have. And you have the peer routing, where you have the peer ID and you match that with a specific location, right? Like, for example, an IP address or something where you can actually retrieve the file. And that obviously is a location, but there might be multiple peers who can serve a content ID. Cool, that's the DHT, and now we kind of have all the pieces together, right? Like we have the content addressing, and we understand how retrieval and routing works in the network. And now kind of we can look at what that looks like in the wild, right? Like there's a couple of different options. if I want to make the content available on the IPFS network, I can run my own node and make it available there and like pay for retrieval and maintaining the infrastructure. I can also add a bunch more nodes to make it more decentralized. They will still be all operated by me. I can pay, and that's kind of option 2 there, what's called a pinning service to do the hosting for me of specific content. Or I can hope that David downloads a file from me and then replicates the content ID and becomes himself a IPFS node that can serve this content. The problem with these guys is like we kind of lose the magic of like trustlessness, right? Like on the like 1A, 1B, you'd have to trust. I mean, that I have to trust myself that I can do it, which is kind of like painful because I have to operate all the infrastructure, and like even if AWS has like 5 outages a month, like I would probably be way worse. And with option 2, I'm kind of paying a pinning provider, and I have to sign a contract with them and like have an SLA, whatever. It's like it feels pretty much like the traditional world. And in option 3, who knows? Like who knows if my content is actually popular enough to be replicated across the network? And that's kind of like where I close the IPFS chapter and like open the Filecoin chapter. Because Filecoin is really this addressing that problem, right? Like how can we have the magic of trustlessness, permissionlessness and combine it with IPFS? Filecoin is storage designed for Web3, like from the ground up, right? It's compatible with IPFS and Web3, like all the content addressing. So it uses IPFS as a building block to and shares all the benefits that I just talked about around decentralization and content addressing. And it integrates with a bunch of Web3 networks like Near. It's verifiable, and this is like the really interesting part, and I'll talk about what that looks like in a second, via cryptographic proofs. And so you ensure that the storage providers who are saying that they're storing your data are actually doing that, and you're doing that in a trustless, transparent way. And what's cool here is that we kind of have both a carrot and a stick, right? So to make sure that storage providers are actually doing what they're claiming to do, the Filecoin protocol pays block rewards if you keep storing the file or kind of keeping to do that. And it uses collateral slashing as a penalty, kind of the stick, if you don't abide by your deal. And overall, this, like the block rewards and like how this all comes together, and because I think it's like a magical idea, and we've now grown to 18 million terabytes of storage capacity, provided by thousands of storage providers over the kind of planet. 18 million terabytes is about 1% of total cloud storage in the world. And it's still growing like super rapidly. So I don't know, when I see this number, I'm like, that's insane, right? Like we had the mainnet launch in October. Like think about that, like, I don't know, like 18 million terabytes is just massive. And it's governed by consensus instead of a single corporation. Let's look into this like center section there, the verifiability. I'll talk you like through the anatomy of what we call a Filecoin storage deal. You or your app, like that's step 1 there, make a deal with one or multiple storage providers to store your data. Those, like the Filecoin protocol, preps your data and transforms them into this directed acyclic graph that I talked about when we talk about IPFS. And it uses the same process, so fully compatible. Step 2 is then the storage provider will generate what we call a proof of replication. So they're just basically like confirming that they have indeed like replicated your data. And then they publish that proof to the blockchain. The third step is then like over time, as you kind of walk into the future, providers prove that they still have like random pieces, random subsets of your data. And we call that like proof of space-time. Like, so they're storing space over time, proof of space-time. Anyone at any time can check for those proofs that the data is actually still being stored. And providers kind of, as you go into the future, are paid incrementally for keeping up the storage deal that they committed to. At the end of a storage deal, clients can get their data by making a retrieval deal. They can let the deal expire, at which point it'll just kind of disappear. Or the dotted line here, they can just like launch a new deal, right? They just renew the deal, they roll it over. And so that's kind of where you have persistence built in with these proofs. And then you can build however long timescales you want with Filecoin. And just to illustrate that a little bit, how like Filecoin deals are really like the building blocks for verifiable permanent storage. I think that's like something that a lot of folks have like trouble wrapping their head around. They're like, oh, but Filecoin is like, it goes away, right? Like it doesn't have to, right? So what you can do is you can basically sequentially over time renew Filecoin deals, and like as with, you would think that the Filecoin storage deal price probably declines over time because storage gets cheaper. You can also kind of build redundancy by like stacking multiple storage deals on top of each other, right? So now you're replicating the data. And what's really like interesting here is like with IPFS, you have like this full modularity. It's completely up to you. It's like, it's completely storage layer agnostic. So I'm just going to read this long subtitle, but I think that like sums it up. Like the magic of CIDs is that they're a property of the data itself, right? So regardless of whether it lives on your computer, a centralized cloud, or some other decentralized storage network. So here, like just to illustrate that, you can make a Filecoin deal, or you can use a pinning service, or some centralized provider. You can use them together, or you can also choose to use a permanent storage option. But because you have persistence and you have this deterministic proof that the data is actually still there, you can. That's the key primitive that you need. And then permanence is just a version of persistence, and that's kind of what I wanted to highlight here. Cool. IPFS and Filecoin they complement each other, and like when I say that, I'm like, so I like kind of put my business hat on, and like I think about this like from a business or like from an economic perspective. That's super interesting. Like IPFS or Filecoin to IPFS is kind of like milk to cereal or gas to cars. Or all the things where, like, when you commoditize the complement, which like Filecoin does for IPFS, you actually have you unlock like a huge growth engine. Like, if gas wasn't a commodity, then probably nobody would be driving cars, right? Because you have like super volatile prices. So that's actually a good thing for growth. And so IPFS, fast and flexible retrieval by gateways, local nodes, and then Filecoin kind of for persistence and verifiability. That's how those come together. Cool. Hopefully, understand how IPFS and Filecoin are different and how they really complement each other. I'm going to spend the next 3 minutes talking about some tools for builders. And so when you think about IPFS and Filecoin kind of at the bottom here, those are hard protocols to deal with, right? Like you need to be a super skilled engineer to actually be able to interact directly with the protocol. And so what folks like David are working on, and he'll talk about that in a second, is building an abstraction layer that you can use it as a storage helper and that take out all that complexity, right? So you have simplified deal making, defining the providers, negotiating prices, waiting for confirmation. All of that is done by these tools, and you can store to both IPFS and Filecoin, retrieval and persistence with a single call, right? And then when you have that, you can build all sorts of fun things on top of it, right? You can log in with a decentralized wallet, and you can load the front end from IPFS, and you can even, in some decentralized web browsers like Brave, instead of typing in HTTP, you just type in IPFS / and then put in your CID, and it'll retrieve it straight from the IPFS network. Or if you want to use Chrome, you can do HTTP, a gateway of your choice, / and then the CID, and you retrieve the IPFS address file. And let me click into some of these from that yellow bar. So the first one is Fleek, which is designed for censorship-proof websites and for kind of web apps. It works with most modern frameworks. And how it works is you connect it to your Git repository, and then you deploy your site straight to IPFS. If you go to hackathons.filecoin.io, that site is actually deployed via Fleek. So if you open it in Brave, you can click the little icon that says open via IPFS. Web3 storage is kind of general Filecoin IPFS storage, super familiar and simple interfaces, and the data is immediately available. 1 terabyte is always free. I won't talk about this in detail because David will in just a second. And same for NFT storage. The only thing that I want to kind of highlight here is we're now storing over 25 million NFTs via NFT storage, and it's OpenSea uses it in Imagine Eden in the Solana ecosystem, so a bunch of kind of folks are using this thing. What you see there is you have this redundancy built in, right? 8 times on Filecoin, and that's the stacking on top of each other. Yeah, there's like a decentralizing kind of in the works, so you can actually have that like perpetual renewal of storage deals, but you don't have to trust the centralized team or anybody to do it. It will be operated by a DAO and maybe eventually via a smart contract. PowerGate is like for power users. I think that's like probably an accurate description there. It's a Docker container wrapped around an IPFS and Filecoin node. And it gives you a lot more options to kind of configure who you want to make deals with. And yeah, just encourage you to check out for all of these just the websites and kind of read through the docs and see if that works for you. Cool. With that, let me just talk about the possibilities a little bit. So this chart you've seen, you have kind of the Filecoin IPFS nodes at the bottom, and then there's a bunch of tooling available to actually make it easy to interact with those. Those are the storage helpers. You can use Ethereum, Near, Hedera, and other kind of smart contracts to build logics around it. The one thing that I want to like point you to is like in the orange box on the far right, that's the logo of the Filecoin virtual machine, which we're launching in the summer. So at that point, you'll actually have storage and compute on Filecoin. And then you have all sorts of front ends that you can have fun with. This is, Build Week, and I hope a lot of you are builders and are, hopefully doing some fun hacking, either, during this event or beyond. And there's 11 project ideas on this slide. I won't go through them in detail, but there is a ton of opportunity, right? Like storage is such a fundamental component that, I think there's a lot of fun things that you can do around video, around NFTs, around gaming, the metaverse, and social networking. It's the sky's the limit, right? Like just like read through this, and you can also go to our hackathons.filecoin website and filecoin.io and check out the Hall of Fame to see what other people have built and how they have won at hackathons. And so really like tons of things that are out there. And then don't just think about like building the next app or like, kind of on the front there. There's a ton of opportunity, even if you kind of like go deeper into some of the other layers. Like if you're excited about hardware and networking and you want to build a Web3 data center, like there is opportunity there to build like a fun venture, and that's just kind of true, right? At each kind of layer, you have different, drivers of defensibility, and kind of different business models that might work. But encourage you to kind of look at that. There's literally like, a whole universe of opportunities for people to kind of build. And hopefully you find us at this event, and maybe let me just pull up the learning resources here. You can find us at our event. So there's a bunch of folks kind of from our ecosystem around. We have a booth. We have a lot more events coming up, like scan the QR code if you want to see where else you will be able to find us at this event, and then just dig in and like go to our docs and go to the easiest way to probably find it is on the Hackathons website again. You can also there book office hours with our team of developer advocates. So just like schedule 15 minutes, like dig in, ask them your questions. We'd love to kind of have you get started. And then join our Discord and Slack and follow us on Twitter and all of that, like whatever floats your boat. Cool, that's really the end of my talk.